Well, cool. I'm Riley. I worked on a metamorphic map of the West Yilgarn Craton. The original talk title is short, but to give it some kind of qualifiers, it's a mineral assemblage-based qualitative metamorphic facies map of the West Yilgarn Craton. That was too long, so they made me change it. Anyway, we've talked a lot about metamorphism today, or I've heard kind of whispers and mingles of it, but just to show our current kind of quantitative understanding of metamorphism, we only have about 28 published metamorphic history records across the entire state. Those represented by the little triangles on the side here. Those each give us a more constrained pressure and temperature, which can then be related to our nice PT diagram and indicative of a facies. And sorry, Rose, I used rainbow colors today because they make me happy. But just to reiterate how complicated metamorphism can be to calculate and constrain, a quantitative metamorphic classification involves a lot of different steps. First, we have to get the sample, make sure it actually has minerals that can be modeled within our PT systems, do really detailed petrographic work on the thin sections using TEMA to help get those mineral classifications even more honed in, then getting our bulk geochem via XRF, get those, convert the whole rock percentages to molar, and then finally put it into our PT calculation things like thermocalc or perplex, and then half the time it doesn't even work because the assemblage just was not compatible with our families in our PT diagrams. So each of those 28 points did take a lot of work and effort. There's more than 28 in this map because there's some unpublished ones in there that have yet to be confirmed or quality checked, but for this purpose I left them in. And just to look at the scale over here, so I'll be using this color for the whole time, but it's hopefully intuitive with green schist representing by green color, granulite, and amphibolite as we're getting hotter by oranges and pinks. So yeah, just to point that out before we move on. To show a better visualization instead of just point data, I decided to interpolate it just to show the real issue we have with our current metamorphic constraints and data sets. While we do have a nice PT constraint or a quantitative set, when we go and interpolate that, turns out everything is granulate or amphibolite facies in the West Yilgarn, which is really exciting if you're a metamorphic petrologist because you're like, oh my God, garnet everywhere, yay. That's not the case, sadly. So there's a lot of detail to unveil still in this area, especially when we consider the scale at which we're looking at. If we compare it to something where you can physically walk over the Barovian or Buchan sequence with those metamorphic index minerals coming in and out as you're walking across these grades, we actually have a lot more detail to hopefully unveil here. So getting something where we actually collate all these different observations together would be really useful and hopefully further constraining structures and timelines of metamorphism. So the way we decided to attack it is looking at qualitative mineral assemblage-based metamorphic data. I won't bore you by going through all the different index minerals through this and things that we find exciting, but the bigger thing here is identifying those in all of our different data sets and having something that almost anyone can look at and have an inference of what metamorphism is like in that area based on this data set. So again, we could take our sample like before where we had our garnet, our cordierite, we had some plagioclase and biotite and a little bit of selimanite in there, and we can identify it as a granulate facies rock rather than getting that PT constraint really honed in and tight. One other thing I just want to point out is when you go to interpolate data sets, they don't really like words, they prefer numbers. So we also had to come up with a relative metamorphic code in a numeric system that kind of just ranks the different facies in that way. So we can actually interpolate the data in a relative qualitative metamorphic set. So going into that, we have a lot of really good record keeping here at the survey. So we have things like petrographic reports that detail sample that are observation-based petrographic reports dating back to the 1950s. So we decided to start the work on the metamorphic map around the seismic lines with some of those are older databases like the petrographic reports. That involved going in and using AI to hopefully extract the reports as word for word. And before you ask, yes, I tried to get AI to do this. It does not understand metamorphism quite so well and thinks that quartz is the biggest indicator mineral for metamorphism. So in total, we've looked through over 6,000 different sample descriptions. And these have been cross-verified by myself and Matt DePauli. So we've looked at each other's work to make sure the metamorphic classifications are legit and kind of consistent across all these data points. In total, we've done about 4,900 metamorphic fascies classifications. And then just on this map, you'll see this pink polygon in a couple different slides. That's just to show where we're pretty confident with the data sets where we built them up now. Again, we focused most of our extraction between the petrographic reports and our Warrock sample sites and observations to match where the seismic line interpretations were going on to aid in those interpretations. So yes, lots of petrographic descriptions, but this is a huge increase in metamorphic data that we've had. Again, 28 published MHRs compared to now 4,000 metamorphic data points is pretty big. And this just shows the data density of the samples. Obviously, there's bias, more leaning towards outcrop, which is not super prevalent, but I digress. So the first data set that we're delivering on or hoping to deliver on is that point-based metamorphic fascies classification. So you'll get color-coded sample points that give you a metamorphic fascies based on the observed assemblage at that point, which you don't have to guess anymore because we now have one clean data set, or we'll have soon. Another issue that came up with some, not issue, but concern was that because we're using multiple different data sources like the PET reports and Warrock samples, we often have an overlap of two different sample descriptions. This didn't happen as much, but we wanted to be really careful with it. We're going to get something that said, like, this one's lower green schist, someone else described it as upper green schist. So we decided to create a minimum and maximum metamorphic map, which you'll see in the next slide, that hopefully represents those different sample description discrepancies. For the next slide, I'll show the interpolations, but just to go over how we decided to create those, we used a natural neighbor technique, which is best for categorical data, which metamorphic data is categorical. As far as time slicing goes, we don't have beautiful time slices like Rose does yet, because we kind of just wanted to get that fundamental understanding of metamorphism across the Western Yilgarn. But one time slice we did include was removing all unmetamorphosed dolerites, unmetamorphosed rocks, including granites, any sedimentary features, or any cross-cutting dikes that were in the data set. This just removes some of the bias that those would kind of lean towards with the interpolation. Well, with that being said, did it work? I hope. So you can see now, compared to our MHRs, where we have a really strong granulate pool, we actually are able to look at the different fascies in an interpolated method now. I still think the point-based data set would be the best to play with if I was like going out and wanting to understand, because interpolation techniques can really affect and bias what we're looking at. Overall, though, we are seeing a lot of those trends that Raf and Yvonne and Tim mentioned this morning, especially around the CTZ. You can see we do have that strong granulate fascies trend through here. Yes, this is an ongoing project, hoping to add more data to this as we go, but it is a very timely process still, going through a bunch of different petrographic reports and reading them. And hopefully we'll come up with some better models to do that, because I'm going insane reading reports. But I digress. We're hoping to deliver on this as far as products, a metamorphic map with these interpolations, the minimum, maximum, again, that point-based metamorphic fascies classifications, hopefully by the end of the year. And as far as going forward, we do want to keep moving this project into the next terrain. And yeah, that's me.